Assalamualaikum Lena Zabainun and also everyone. Before we start, let us introduce ourselves. My name is Anis Nazurah binti Abdul Razak.
Hi, I'm Nakia binti Zulkifli.
My name is Siti Saleha.
My name is Noalia Bashira binti Nur Israj.
My name is Tini Shaira binti Disham Shuri.
We from group AS12018. So today, we will present about experiment 4. It is linear motion. So I will start with objective in this experiment. First, to investigate the relationship between force, mass, and acceleration. Second, to determine the acceleration of an object under a varying force. Next, this is a few apparatus that we need in this experiment. First, a thread reel. Second, blower, pressure tube, gliders, flag, photo gates, masses, mass hanger, string and pulley. So this is diagram that we need to arrange all the apparatus to be like this.
The procedure are, the first one is the linear air track is set as shown in figure 4.3. Second one is the pump is switched on and air is allowed to flow through the track for several minutes. The track is then balanced by adjusting the screw on its leg until the glider is kept stationary when released without being glided to either end. The third one is a hook is inserted at one end and the flag is placed on top of the glider. The fourth one is the mass of the hanger, mass of the glider and the length of the flag is measured and recorded. The fifth one end of the string is attached to the hanger and the other end to the glider. The sixth, masses of 20 gram is placed on the hanger and the 80 gram on the glider. Then the string is placed over the pulley. Seventh, the glider is positioned exactly before the photo gate. The glider is released and the time shown on the photo gate is recorded. Note the order to avoid masses from crashing to the floor and scattering. The glider is catched with hand before the hanger reaches the floor. 8. The experiment is repeated 2 more times to obtain the time average values. 9. Then the slotted mass on the glider is decreased by the transferring mass of 20 gram onto the hanger. Steps number 7 and number 8 is repeated. 10. The procedure is repeated 3 more times with 20 gram from the slotted mass on the glider added to the hanger. And now I will talk about our obtained result. So the length of the flag X is 10 with uncertainty of 0.05 multiplied by 10 minus 2 meter. Mass of glider and flag M1 is 200.05 with uncertainty of 0.01 multiplied by 10 minus 3 kg. Mass of hanger M2 is M2 10.11 with uncertainty of 0.01 multiplied by 10 minus 3 kg. So here are the results. I will talk it one by one. So total of slotted masses on glider M kilograms. Start by 80 multiplied by 10 minus 3, 60 multiplied by 10 minus 3, 40 multiplied by 10 minus 3, 20 multiplied by 10 minus 3. Next, total of slotted masses on hanger M kilogram, 20 multiplied by 10 minus 3, 40 multiplied by 10 minus 3, 60 multiplied by 10 minus 3, 80 multiplied by 10 minus 3. And next is time taken, which is with uncertainty of 0.001 second. So T1 is 0.161 and 0.125, 0.104, 0.092, and the T2 is 0.136, 0.124, 0.105, 0.093. So the average is for the first one is 0.1262, and second one is 0.125, the third one 0.105, and the last one is 0.093. Square of time taken, S square. First one is 0.026, 0.016, 0.011, 0.0086. So, and the total mass of glider and sorted masses is it is M1 equal to M1 plus MA in kilogram. The first one is 0.28005, 0.06, 0.26005, then 0.24005, and last one is 0.22005. Next is total mass of hanger and slotted masses. MT2 is equal to M2 plus M beta in kilogram. So the first one is 0.03011. Next is 0.05011. Next is 0.07011. Last one is 0.09011. And weight of hanger and slotted masses, F equal to M T2 multiplied by gravity. The first one is 29.5 multiplied by 10 minus 2. Next one is 49.2 multiplied by 10 minus 2. 88.8 multiplied by 10 minus 2. 88.4 multiplied by 10 minus 2. And last one is acceleration, is A equal to 2x divided by t square. 7 is 7 point, first one is 7.692, second one is 12.5, third one is 18.18, and the last one is 23.256, and you can see the first one is.
This is a plot graph of weight force against acceleration by taking the data from the result that have been explained previously from my group members earlier. From the weight force versus acceleration graph, it can be observed that the graph is a line graph with acceleration on the x-axis and weight force on the y-axis. As you can see, the constant gradient of the graph indicate the mass of the experimental value. And after we plotting the graph, we calculate the central point of the graph. Thus, the central point of the graph that have been calculated on the x-axis is 58.98 times 10 to the power of negative 2, and for the y-axis is 15.41. And then after we find the central point, we can find the best fit line, maximum line, and minimum line. Now we are going to determine the gradient of the graph. As I explained earlier, the gradient of the graph represents the mass of the object. This is because from Newton's second law equation of motion, which is F equals to ma, we can compare it with the equation of linear graph, which is y equals to mx plus c. When, as we can see from the comparison, the gradient of the graph is equals to the mass of the object. Next, we have to find the gradient of best fit line, maximum line, and minimum line. For the gradient of the best fit line, we have to find the maximum point and minimum point on the best fit line. So from the graph, we can find that the maximum point we take is 23 and 90 times 10 to the power of negative 2. For minimum point is 1.4 and 5 times 10 to the power of negative 2. And when we put the value into the gradient formula, we can find that the gradient of the best fit line is 39.35 times 10 to the power of negative 3 kg. Now to find the maximum gradient, first we have to find the maximum point and minimum point on the maximum line. So from the maximum point that we take is 21.6 and 90 times 10 to the power of negative 2. And for the minimum point, we take 4 and 6 times 10 to the power of negative 2. And then we're going to take the maximum and minimum point value and put into the gradient formula. We can get that the gradient of maximum is 0.04773 kilogram. And for the minimum gradient, we find that the maximum point is 24 and 88 times 10 to the power of negative 2. And the minimum point is 0 and 10 times 10 to the power of negative 2. Then we take the value of maximum point and minimum point and put it into the gradient formula. Then we get the gradient of minimum is 0.0325 kilogram. Now we are going to determine the uncertainty of the gradient. To find the uncertainty of the gradient, we could use the following formula, which is uncertainty of gradient is equals to 1/2 bracket maximum gradient minus minimum gradient bracket. So 1/2 bracket 0.04773 minus 0.0325 bracket. Then thus the uncertainty of gradient is equals to 7.615 times 10 to the power of negative 3 kg. Therefore, the gradient M, or the mass, is equal to 39.35 plus minus 7.62 times 10 to the power of negative 3 kg. And lastly, I'm going to explain the relationship between the gradient of the graph and the total mass of MT equals to MT1 plus MT2. The gradient of the graph represents the total mass of the object based on the formula of F equals to ma. Since the graph plots weight, force over acceleration, the gradient m equal to F over a, which is equal to the total mass.
So the first question is calculate the percentage difference between the gradient m and mt. So the question is, what is the percent error in this experimental value? So to find this percent error, we need to find the mass first. So the calculation is mt equals to mt1 plus mt2. So mt1 is equals to the number for mt1 is 0.28005 plus 0.03011 for mt2, and we got the mass is 0.31016 kilogram, and based on the gradient, the m is 39.35 divided by 10 kilogram. So the percentage difference, as you guys can see the calculation, so the answer is 154.97%. To find the percent error, this is the calculation, and The answer is 87.31%. So the next question is, discuss the factors that have contributed to the errors in the experiment. So the answer is several factors may have caused the difference between theoretical and experimental value. Firstly, friction. So the first factors is friction between the glider and the track. Pulley resistance and slack or stretching in the string could reduce acceleration. Secondly, misaligning the photo gates caused the glider or object to not pass through the beam cleanly. And the third one was the wire or connectors is loose that may interrupt the data.
For the last question is, explain how to overcome the factor mentioned in 2. To overcome the factors, make sure the air track is clean from dust to remove friction. Then, upgrade the pulley to the one with low friction bearings to minimize pulley. Next, use a non-stretchable string, for example cotton, or thread with minimal elasticity. Secondly, repeating trials and taking average would also help improve accuracy. Furthermore, make sure to adjust the photo gates to be level and aligned with the glider's path. Lastly, make sure to secure all cables and check connection before starting.
So let's begin with question 1. We were asked to calculate the percentage difference between the total gradient value of M and the total theoretical mass MT. From the calculation, MT is equal to 0.31016 kg. M from the gradient is equal to 39.35 times 10 to the power of negative 3 kg. The percentage difference is calculated 39.35 times to the power of negative 3 minus 0.31016 divided by the average of the two times 100%. This gives us a percentage difference of approximately 154.97%. Then we calculate the percent error using the formula experimental minus theoretical divided by theoretical times 100, which gives a percent error of around 87.31. Moving on to question 2. We identified several factors that could have caused the significant difference between the theoretical and experimental values. So the first one is friction between the glider and the air track, as well as resistance in the pulley and stretch or slack in the string, which can all reduce the expected acceleration. Second is misalignment of the photo gates, which might cause the glider to not pass through the beam properly, affecting the timing. Lastly, loose wiring or connectors may have interrupted the data collection or introduced delays. Finally, question 3. How to overcome these issues? So here are the solutions. First, clean the air track before the experiment to reduce frictions. Second, use a low friction pulley with proper bearing to reduce resistance. 3. Choose a non-stretchable strings like cotton thread to avoid energy loss. 4. Repeat trials and average of the results to reduce the effect of random errors. 5. Make sure the photo gates are aligned with the glider's path for accurate readings. Lastly, check and secure all connections and cable before beginning the experiment to avoid data interruptions. In conclusion, understanding and minimizing these experimental errors is crucial for obtaining accurate data or results that closely match theoretical predictions. Next, let's move on to our conclusion. To conclude our experiment, we successfully demonstrated the relationship between force, mass, and acceleration in line with our objective. From the graph force against acceleration, we observe a linear relationship which confirms Newton's second law of motion, F equals to ma. This linearity shows that when the mass is kept constant, increasing the net force results in a proportional increase in acceleration. Next, when we varied the force while keeping the total mass constant, the acceleration of the object also increased. This tells us that acceleration is directly proportional to the applied force and inversely proportional to the total mass of the system. Furthermore, the slope of the force versus acceleration graph allows us to determine the mass of the system, which can closely match our theoretical expectations. Overall, this experiment achieved its objective. We explored the relationship between force, mass, and acceleration, and we determined how an object's acceleration changes under varying force using both qualitative observations and quantitative data.
So that's all from us. Thank you.